Hello everyone, I'm Zhi Wang, and I will present our research on visual prompting in large language models for enhanced emotion regulation. Our approach used visual prompts to improve emotion regulation accuracy. Emotion regulation is a complex task that involves decoding subtle cues like facial expressions, body language, and contextual details. Our approach used a set of vision prompts focus on spatial relationships between facial features to improve recognition accuracy. By combining this with vision large language models, we address these gaps in previous methods and enhance the model's performance in identifying emotions. Our set of vision prompting method enhances emotion regulation by preserving the full image context and highlighting key facial regions. Unlike traditional methods that crop faces, by integrating spatial visual prompts and an overlap handling algorithm, we significantly improve the accuracy of vision large language models, especially in dense face clusters. First, we use bounding box to identify and locate faces in the image. Then we enhance the grounding capabilities by assigning numerous boxes to differentiate the faces. Finally, we incorporate facial landmarks to analyze the spatial relationships between facial features, such as the eyes, nose, and mouth, which are critical for fine-grained emotion classification. This multi-stage visual prompting strategy enables vision large language models to accurately detect and recognize emotions in real-world images, while preserving the global context of the scene. Through this approach, we aim to improve the overall performance of emotion regulation systems in complex environments. Next, let's compare emotion regulation methods in a group setting, highlighting the impact of our set of vision prompting approach. In the first example, a standard plain text prompt identifies 22 faces, but lacks accuracy in analyzing facial features and expressions. By using our set of vision approach, the second example improves accuracy, identify 18 faces with detailed emotion analysis through facial landmarks and bounding boxes. This method captures subtle expressions, like slight smiles and eyebrow movements, providing a more nuanced understanding of group emotions. In this section, we review the related work. Large language models like Llama, ChatGPT excels zero-shot neutral language tasks, while vision large language models such as MiniGPT-4 and Llama focus on imaging-related tasks, but often require fine-tuning. Our research introduced a zero-shot architecture for emotion regulation, eliminating the need for task-specific adjustments. By using visual prompts like bounding box, numbers, and facial landmarks, we preserve spatial context, improving the accuracy of emotion regulation compared to traditional methods. Our goal is to match each visible face with its corresponding emotion. Using a set of vision prompts, we detect faces using bounding box, handle overlaps algorithm, and analyze facial landmarks to enhance emotion regulation. Finally, we use both plain text and combined text vision prompts for comprehensive emotion analysis. Our set of vision prompting approach for face recognition begins with detecting numerous visible faces in the image. We then identify key facial landmarks such as the nose, eyes, and mouth to conduct a spatial relationship analysis. This multiple-step process enhances emotion regulation by ensuring accuracy identification and analysis of each face's expressions and spatial relationships. Face detection often faces challenges like overlaps, occlusions, or misaligned landmarks, which can confuse within large language models and lead to errors in emotion regulation. Our approach addresses this by detecting and handling overlaps, ensure that correct labels and landmarks are applied by prioritizing larger and more visible phases. This method reduces errors and improves the accuracy of emotion detection in complex scenarios. Our approach used two types of prompts for emotion regulation. Plain text prompts analyze group emotions, providing an overall understanding of the scene, while combined text and visual prompts offer a detailed analysis of individual emotions by focusing on facial expressions, body language, and context. This dual approach allows us to evaluate both group dynamics and individual emotional status in social interactions. In the experiments, we validate our approach through model settings, dataset details, quantitative results, visual prompting analysis, and an evaluation study to demonstrate its effectiveness in emotion regulation tasks. This table compares various zero-shot emotion regulation methods, including MIDI-GPT-4, Lalava, Video Lalava, and GPT-4, across the different difficulty levels. Our approach shows significant performance improvements, especially in more challenging conditions. Notably, our method achieves the highest accuracy and recall, demonstrating the effectiveness of visual prompts in enhanced emotion regulation. So this table compares state-of-the-art method for zero-shot emotion regulation across various difficulty levels. Our approach, which integrates numbers and facial landmarks, consistently achieves the highest accuracy and recall, outperforming methods like reclip, red cycle, showcase the strengths of our vision prompting techniques. So this study compares different vision prompting methods, including reclip, red cycle, and our approach. While red clip and red cycle play non-facial areas, our methods emphasize the facial features while preserving the background information, needing more accurate and detailed emotion regulation. This bar chart compares the performance of our methods, red cycle and red clip, in recognizing 7 emotions. Our methods consistently outperform the others, particularly in recognizing emotions like happy, neutral, and angry, showcase the effectiveness of our visual prompting methods in emotion regulation. This evaluation study shows how different visual prompts impact GPT-4's performance. Our methods, which combine facial landmarks and numerical identifiers, achieves the best results across all difficulty levels, demonstrating the effectiveness of spatial visual cues for improved emotion regulation. This study shows how segmentation masks impact emotion regulation. Our method preserves facial details and context, leading to clear emotion regulation, while segmentation masks obscure key facial features, making it hard to accurately identify emotions, particularly for person 2. In conclusion, our approach used the face overlap handling algorithm and combined text vision prompts to enhance the emotion regulation while keeping the full image context. Our set of vision prompting methods significantly improves zero-shot emotion regulation accuracy in vision large language models by ensuring accurate face detection and emotion classification. Thank you for your attention and interest in our work. We greatly appreciate your time, and we hope our findings contribute to advancing emotion recognition in Weixin large language models. If you are interested in learning more or accessing the resources we have shared, please visit the link or scan the QR code. We look forward to your questions and feedback.